Okay, so this is something that you've seen earlier in this lesson. I didn't tell you what it was called, but it is called a ray. A ray is half of a line and it extends infinitely in one direction. So a ray is kind of a hybrid between a line segment and a line. You see it has one end point right here, and that's actually called the initial point. So this is the initial point. That's where the ray starts. If I labeled this A, I'm going to put this other point on the line on the ray B. This is ray A, B, and you write this like this. So there's an arrow on one end, and it goes on the end that has an arrow in the diagram. You cannot label this ray BA because it starts at A. So the initial point always goes first. This is wrong. Something interesting about rays, since a ray is half a line, two opposite rays form a line. And opposite rays have the same initial point. So an example of that would be if I had over here point F, then I would have ray AF, and that goes in the opposite direction. But A is still the initial point, so you always start with writing A. And AF and AB are opposite rays. Okay. Now we want to draw three collinear points, A, B, and C. The way that I'm going to do that, I'm just going to draw a line like this. And collinear means that they are on the same line, so I'm just going to put 3 points on the line. A, B, C. So those are three collinear points. Now we want to draw point D, which is not collinear with A, B, and C. So that means it's not on the same line. You could put it basically anywhere except for on the line. So there's my point D. Now we want to draw line AB. So line AB, oh, well, we already have that because A and B are on the same line. And ray BD, so I need an initial point at B, and then the ray extending through point D and beyond, like this. So you're just really taking this problem one piece at a time, and we have everything that it asks for, so we're done. Example 7. Name all pairs of opposite rays in the figure. Now you can only name an opposite ray if you have the 2 points to name it with. So I'm going to start with F as my initial point. I would like to be able to start with E, but I can't because there's nothing over here. If I just say ray E, it's not really clear which direction I'm going in. So we're going to start with F, and I do have a ray, FE, so starting at F going through E. And opposite of that, we have either FG or FH. So we could have said this, and FG and FH are exactly the same, so this is kind of repetitive. Next, let's move to point G. So we have ray GF. You could have also said GE. And in the other direction, GH. So starting at G, passing through H, and continuing. So you really only have 2 pairs of opposite rays in this diagram. All right. This is an angle, and that should be something that you've heard of before. An angle has two sides, so this is a side and this is a side. These two rays are sides, and the vertex is this point right here. So on a ray, this would be the initial point, but on an angle, we call it the vertex. Here are those definitions. So an angle is two different rays that have the same initial point. So you can see here's a ray, and they connect at the vertex or the initial point. The sides of the angles are the rays, and the vertex is the initial point. We want to name the angles in this diagram. Example 8, name the angles. And some of these are pretty easy. So you need 3 points to name an angle if you're using points. The vertex is always named in the middle. So first, we have, let me highlight this, angle BAC. Oh, let's do it a little bit. First, we have angle BAC. So the first angle starts at B, A is the vertex, and then it goes through C. You could have also named this angle CAB. That would be the same angle. Okay. Next, we have angle CAD. So again, starting at point C, or on the side that contains point C, I should really say, passing through vertex A, and then to the side containing point D. This is the same thing as angle DAC. There's one more angle on here, and that is the big angle. So BAD, angle BAD, which is the same as angle DAB. And again, notice that A is the center point in every single one of these because A is the vertex for all 3 angles. A second way to name angles, sometimes your diagram will not have points labeled on the sides of the angle. It will only have a number or maybe a letter written inside the angle. So here, this is angle 1, and then this one is angle 2. And this is really, it's kind of nice because it's a shorter angle name to write, but the disadvantage of this is that you cannot name the entire angle. So this larger angle doesn't have a name in this diagram. All right, almost done with this lesson, guys. So this is a circle. You have seen circles before. In our circle vocabulary, there is the center of the circle, which is in the center. The circle itself is actually that outline. So all this white space in the middle isn't really part of the circle, just the outline. So the black and then this blue portion over here. You have 2 radii here. So this is a radius and this is a radius. The plural is radii. And that is a segment that goes from the center to a point on the circle. So from the center to a point on the circle, they're all the same length. Last, we have an arc, and that is this blue portion here. It is a portion or a part of the circle. So it's some length of the circle. Okay, and here are those definitions. We have radius. So a radius is the distance from the center of a circle to a point on the circle. It is a segment whose endpoints are the center of the circle and a point on the circle. Circumference is the distance around a circle. So this is similar to perimeter with other shapes. And then last, we have arc. So that might be referred to as a circular arc. That is the segment of the circumference of a circle. And this is our last example for this lesson. We are going to construct a circle with center O. So let me begin by drawing that center point right here, labeling it O. And what you want to do is just take your compass and put it on that center point. And you want to be very careful doing this. You don't want to adjust the compass width at all. You're going to swing it around in a circle. So if you go all the way around, you get a circle. Now we're going to draw point R on the circle. So point R, it could be anywhere, it doesn't specify where. So point R. And construct radius RO. So you're drawing a line segment between R and O for your radius. Draw point T on the circle, and your point T could be anywhere. And construct radius TO. So now we have two radii, which are the same length, and that is it for lesson 1.